Welcome to STEM Baba. In this video, we'll discuss the problem and conceptual exercises of chapter 4 from the book James Walker. So let's start. So to solve this problem, we have to take the reference of the previous problem. So first, I'll be solving the problem 34 and then we'll get back to this question. So in problem 34, it is given that snowballs are thrown with an initial speed of 13 meter per second from height 7 meter above ground. Now one ball is thrown straight down and another ball is thrown at an angle 25 degrees above horizontal. And we have to figure out, is the landing speed of ball A is equal, greater or less than the landing speed of ball B. This is ball A, this is ball B. And we have to also prove the results by using equations. Okay, now this kind of problem I've discussed earlier also, the cat problem that I discussed. So the answer would be that the landing speed will be same, and the reason is since the height from which the ball is released is same for both the case and also the initial speed is same. So these are the two conditions. If the height is same and the initial speed is same, no matter in what direction the ball is released, either this is released in the upward direction, downward direction, doesn't matter, the landing speed will be same, provided that the height from which the ball are released is same and also the initial speed is same. So the answer would be that the landing speed is same for both ball. Now we have to prove it also. So let's first consider this ball A. Now this ball A is thrown straight downward, and this point, this is the ground, the direction of the velocity will be vertically downward direction. So what would be Vy here? We don't know, that we can calculate by using equations. And Vx, there is no component of velocity in the x direction, so Vx is 0 for ball A. Okay, so for Vy, what we can do is we can use this equation. Vy square minus V naught y square is equals to 2a delta y. We can use this equation of motion. Now V naught y, initially the ball is thrown vertically downward and we have taken this to be positive, so V naught y will be negative 13 meter per second. And acceleration, this should be ay, and in vertical direction ay we have minus g. Then this delta y we have final position minus the initial position. This is the final position, so yf is 0, and this is the initial position here. This height is 7 meter, right? So y initial position is at 7 meter. So yf minus y initial, it should be minus 7. The sign should be considered very carefully. Now we have all the values, we can plug it here to find the velocity at this point. So Vy square minus V naught y is minus 13 whole square is equals to 2 times acceleration is minus 9.81. Delta y we have minus 7 meter. From here we can easily find Vy, and Vy after rounding off is minus 18 meter per second. And this negative sign is because the direction is in the downward direction. Now Vx is 0. So what would be the speed of the ball? Speed would be under root. This is for speed for ball A. So Vy square plus Vx square. This is how we calculate the speed. So under root Vy is minus 18 square plus this is 0. So speed is 18 meter per second for ball A. Similarly, we can find the speed of the ball B. So let me do one thing. Let me make it just a little bit small so that I can show the trajectory of the ball. Now for ball B, this was thrown at an angle 25 degrees above horizontal. So it will move like this. It will go a little bit up and then it will go down, and this would be the ending point or the point at which the body reach on the ground. So here it will have two component of velocity. The velocity would be something like that, and one component in the horizontal direction and another component in the vertical direction. So in the horizontal direction we have Vx, and in the vertical direction we have Vy. Now let's find out these values, Vx and Vy. So for the Vx, we can consider the motion of the ball in the horizontal direction, and this is for ball B. So we can use this equation. Vx is equals to V naught cosine theta, because the horizontal velocity remains same at all the time. So this Vx will be same as that of Vx, this Vx. So we can write this be V naught cosine theta. V naught is the initial speed which we have given in the equation to be 13. So 13 cos 25. So that will be equals to 12 meter per second. I have just rounded off the answer. This is 12 meter per second. Now Vy. So for Vy, again we can use this equation. So Vy square minus V naught y square is equals to 2ay delta y. Now Vy, this we have to find, minus V naught y. Now here V naught y will be V naught sine theta. So 13 square sine square theta is 25 degrees is equals to 2ay is minus 9.81 meter per second squared. Delta y. Now delta y for this ball B is also same, because this was the initial position and this is the final position. Same for both the ball. So minus 7 meter per second. Minus 7 meter. So from here Vy, this value comes out to be as minus 13 meter per second. Now what would be this speed? Speed would be under root the x component square plus the y component square. This is for ball B. So under root x component we have 12 and y is minus 13. So 12 square plus minus 13 square, and that comes out to be as, after rounding, this would be 18 meter per second. Therefore we have proved that the speed for both ball A and B will be same. Now we can move to this question where it is asking we have to find the direction of motion of two balls just before they land. Okay, so if you consider this ball A lands vertically. So what would be its direction? It would be along negative y direction, or we can say that is theta is 90 degree below horizontal. So this is problem 35. So the direction for ball A on landing will be 90 degrees below horizontal. And what would be the direction for the ball B? Let me show it in the figure. This direction they are asking, this theta. Pretty simple. So tangent theta will be the vertical component over the horizontal component, Vy over Vx. So from here theta would be tangent inverse. Now Vy we have minus 13 and Vx we have 12. So on solving we'll get this value to be minus 47 degrees, or we can write that 47 degrees below horizontal. So this angle is 47 degrees and this is below horizontal. Now to solve this problem we have to refer the previous problem, and it says that a golfer gives a ball a maximum initial speed of 51.4 meter per second, and we can assume that the initial and the final elevation is same. So this is the data that is given in the previous problem. Now in this problem it is asking that what is the highest tree the ball could clear on its way to the longest possible hole in one. Now the golfer hits the ball with some initial velocity, and this will be the trajectory of the ball, and it's land on the same elevation. We can assume this elevation is same. Now what the question is asking, that what is the highest tree the ball could clear? Basically it is asking the maximum height. This height it is asking, h max. Now since the elevation is same, so we can directly use the formula for h max that we obtained in our previous videos, or we can use the basic equations. So I'm going to use the basic equations. So Vy square is equals to V naught y square plus 2a delta y, and this should be ay. In this case ay will be minus g. We can take this to be a coordinate system, y, and then this is x, right? Now we have to calculate h max. So at this point the vertical component of velocity will be 0, because the ball is moving like this. This is v. The vertical component is 0, so this at this point this is 0. v naught y, we have v naught sine theta, the initial velocity, plus 2a is minus g, and what is delta y? This is delta y, delta h. So this we can write h max. We can rearrange the term to find the expression for h max. H max, from here it comes out to be as v naught square sine square theta over 2g. So this is the formula we obtained in our previous videos. Okay, now we can put the values. Now one more thing, there's a catch point here. What would be the value of theta? So for that we have to refer the previous problem, and in the previous problem it says, if you see the A part, it says what is the longest possible hole in one for this golfer. So the range is maximum for which angle? When theta is 45 degrees. So we have to consider that theta is 45 degrees. Now we have all the values, we can put it here. V naught we have 51.4 meter per second, and it's square. Sine square theta is 45. Divide by 2g. So g is 9.81 meter per second squared. So on solving this, we'll get the maximum height to be 67.3 meter. Thus, the maximum height for the tree that the ball can clear is 67.3 meters. Now in this question it says that in a friendly game you hit a ball at the ground level and send it towards the wall with the speed of 16 meter per second and at an angle 37 degrees above horizontal. These are the coordinates, x-axis, y-axis. Now you hit the ball like this at an angle 37 degrees above horizontal with speed 16 meter per second. So the ball will follow a parabolic path, something like that, and it will hit the ball at this point. Let this height be h. Now there are two parts in this question that we need to solve. In the A part, we need to find the amount of time required for the ball to reach the ball if it is 3.3 meter away. So what it says that if this distance is 3.3 meter, then how much time the ball takes to reach to the wall. So it's pretty simple. We can consider the horizontal motion for the ball, so which is x equals to x naught plus v naught x times t plus 1 over 2 ax t square. Now there is no acceleration in x direction, whole term is 0, x naught is also 0, so this time would be x over v naught x. X we have this value, which is 3.3 meter, because horizontally it travels 3.3 meter. So 3.3 meter divided by v naught x is 16 cosine theta is 37 degrees. This would be vx, and this would be v naught x, because this is initial speed in the horizontal direction, and this is v naught y. We can easily solve it for t, and the value of t from here comes out to be as 0.26 seconds. Now next in the B part it says how high is the ball when it hits the wall. So this height h we have to calculate. Okay, so for that we can use this equation, y is equals to y naught plus v naught y times t plus 1 over 2 a y t square. Now y naught is 0 here, so 0 v naught y, we have v naught sine theta. Now we have to find the height. So height, this is h, so this final position becomes h, and time we know it is 0.26, so we can solve it for h. So plus 1 over 2 ay, we have minus g and t square. Now we can put all the values here to find h. So h will be equals to v naught is 16, sine theta is 37 degrees, multiplied with time is 0.26 seconds, minus 1 over 2, g is 9.81, t square is 0.26 and its square. So on solving this, we'll get the height to be equals to 2.2 meter. Therefore this height is 2.2 meter. So this is the final answer. Now it's a pretty simple question. It says that a certain projectile is launched with initial speed v naught, let this be v naught, and at its highest point its speed is v0 over 4, and we need to find the launch angle. This theta we have to find. So at the highest point, this is the highest point, the velocity vector would be something like that. So at the highest point the vertical component is 0, vy is 0, and the horizontal component vx is always constant throughout the motion, which is v0 cosine theta. So at this point the speed becomes v0 by 4, so we can equate it to be v0 by 4 equals to v0 cosine theta. So this v0 and v0 will cancel, so cosine theta is equals to 1 over 4, or from here theta would be equals to 75.5 degrees. So in this question it is given that a dolphin jumps with an initial speed of 12 meter per second at an angle 40 degrees above horizontal. So initial speed we have v0 to be equals to 12 meter per second, and this angle theta above horizontal is 40 degrees. Now the dolphin passes through the center of a hoop before returning to water, and also dolphin is moving horizontally when it goes through the hoop. So when it moves through the hoop, it is moving horizontally. That means the dolphin is at its maximum height at this position, and that is it is moving horizontally with speed v. Now we have to find how high above the water is the center of hoop. So basically we have to find the maximum height. So either you can use the direct formula or you can start from the basic equations. So this time I'm using the direct formula. So maximum height is given by, for this particular case, this is v0 sine theta whole square over 2g, and this formula is valid only when the initial and final elevation is same. So v0 we have 12, and sine theta is 40 degrees, and whole square divided by 2, g is 9.81. So we can solve it for h max, and it comes out to be as 3.03 meter. Now in this question it is given that a golf ball is struck on a level ground and it lands 92.2 meter away after 4.30 seconds. So basically we are given that range is 92.2 meter and time of flight we have 4.30 seconds. Let me show it on the figure. This is the range, which is given to be 92.2 meter and time of flight 4.30 seconds. Okay, now there are two parts that we need to solve. In the A part we need to find the direction, this angle theta we have to find, and the magnitude of initial velocity, so v0. These two things we have to find. Now we are given with time of flight, so we can either directly use the formula for time of flight or we can start from the basic equations. So I'll start from the basic equations. Y equals to y0 plus v0 sine theta times t minus 1 over 2 g t square. I have taken ay to be minus g. Y0, this is 0, and the final position is also 0, so this is also 0. So from here we can write that v0 sine theta times t is equals to 1 over 2 gt square, and from here the expression for time of flight comes out to be as 2 v0 sine theta over g. Now what would be the expression for this distance x? For that we have to consider the horizontal motion. So this will be the component of velocity in the horizontal direction, and this will be the component of velocity in the vertical direction. So in the horizontal direction we can write that x will be v0 cosine theta times t, because there is no acceleration, so we can directly use this formula. Now from here v0 cosine theta, this will be x. X basically is the range, so we can put it as r over t. We have the value of r, we have the value of t, so that will be 92.2 meter, and t we have 4.30 seconds, so that would be equals to 21.4418 meter per second. Now from this equation we can write that v0 sine theta, this will be equals to t g divided by 2, right? So V naught sine theta. T we have 4.30. G is 9.81 divided by 2, so that would be equals to 21.091 seconds. Now if you consider these two equations, let this be equation number 1, this is equation number 2. Here we have V, this should be V naught. So here we have V naught sine theta to be equals to this, and we have V naught cosine theta to be equals to this. So take ratio of these two equations. So V naught sine theta divided by V naught cosine theta. So V naught sine theta we have 21.091, and V naught cosine theta we have 21.4418. Now from here this V naught and V naught will cancel, and from here tangent theta, this will be equals to 21.091 divided by 21.441. We can easily find the value of theta from here, and theta will be equals to 44.52 degrees. So this is the answer for the A part. Now next, in the B part, we have to find the initial the magnitude of initial velocity. So for that you can use this equation. So from here we can write that V naught, this is the B part, V naught is equals to GT over 2 sine theta. Now let's put the values. So G is 9.81 meter per second squared. T is 4.30 times 2 into sine theta. Theta is 44.52. And from here, V naught comes out to be as 30.1 meter per second. So this is the answer for the B part.